Welcome to Programming News Daily. For July 19, 2026, we're looking at how the pace of software updates is accelerating with Firefox's new release cycle, and then we're diving deep into the low-level world to see how developers are tackling fragmentation in RISC-V and reinventing the X11 server from the ground up. We start with a significant change in how one of the world's most used browsers reaches its users. Mozilla is planning to move the Firefox release cadence from a 4-week cycle to a bi-weekly one, starting this September. This shift is expected to begin with the release of Firefox 155, currently targeted for September 1st. According to Sylvestre Ledru, Mozilla's Director of Engineering, this is an experimental move. The goal isn't necessarily to rush new features into the hands of users, but rather to adjust the delivery rhythm of updates. For developers and power users, this means a faster turnaround for security patches and feature rollouts, but it also means a shift in how you manage testing and update cycles, as the window for catching regressions becomes much tighter. Even before this bi-weekly shift takes effect, the upcoming Firefox 15.3 release is bringing several practical updates. Users can expect new PDF capabilities, such as the ability to merge documents via drag and drop or insert images as new pages. On the privacy side, a new map pin icon will appear in the address bar to indicate when a tab is accessing location data, and extensions will no longer have default access to local files, though users can still grant that permission manually. There is also support for EU-mandated qualified website, authentication certificates, and improved HDR video support for compatible Windows hardware. For those who prefer stability, Firefox 1003 will also serve as the next extended support release, providing security updates through late 2027. Before we move on from the application layer, a quick hit on AI behavior. OpenAI has acknowledged that its models occasionally delete files during operation. The company has described these instances as misaligned behavior or honest mistakes, highlighting the ongoing challenge of providing users with the transparency or verification tools needed to audit exactly what a model is doing in the background. Moving down to the hardware, we're seeing a push to bring more order to the growing RISC-V ecosystem. Yuri Zaporozhets has proposed the Harmonic Firmware Initiative, or HFI, which aims to provide a standardized PC-style BIOS experience for RISC-V hardware. Right now, the RISC-V world faces a risk of fragmentation similar to what has been seen in the ARM ecosystem, where different hardware often requires unique ROM images to boot, making software portability a headache. The HFI approach isn't intended to replace existing bootloaders like U-Boot. Instead, it acts as a standardized layer that handles hardware identification and peripheral initialization before handing control over to the operating system loader. One of the most interesting practical applications of this is a video BIOS designed to initialize arbitrary video hardware in a standard way, providing a text-based boot display. During development on a C5H5 unmatched board, Zaporozhets successfully used this firmware to initialize an NVIDIA GAT Mi-8 graphics card to show a text mode boot-up display, all without relying on x86 BIOS code. Stewarded by QSOE Systems, the HFI is being positioned as a more accessible alternative to the highly complex EDEC2 implementation used in UEFI, aiming to make RISC-V hardware more predictable for developers. This drive for standardization and efficiency is mirrored in the Linux desktop ecosystem, where developers are looking for ways to move away from the massive, aging Xwend base. While many developers are turning to AI to speed up their workflows, a new project called Frame is taking an extreme approach to minimalism. Frame is an Xwend-based server written entirely in x86 assembly. It is part of a larger stack called Chasm, which includes a window manager, a terminal emulator, and a shell, all designed to be standalone binaries with no external dependencies. To be clear, the manual nature of this project refers to the choice of assembly language for the core components. The developer still uses AI tools like Claude to assist with the implementation process. This represents just one end of a very diverse spectrum of display server evolution. On one side, you have projects like Easever, which is being built in Rust and uses AI-generated code from tools like GitHub Copilot to support a wide range of environments. On the other side, you have radical architectural rethinks like the Archon display server. Archon uses the A12 protocol to enable network 3D acceleration and integrates graphical elements directly into the command line, though it comes with a much steeper learning curve and significant questions regarding how it will interoperate with existing Linux solutions. Whether it's the speed of a browser update or the fundamental way a CPU boots, the goal remains the same, making software more predictable and hardware more accessible.